Hi, my name is Philip. Today I will talk to you about periodic pattern mining. I will explain what it is and we'll see how it works together. So, you can find my website also. And if you want to try periodic pattern mining, what I will explain today, you can find the code and datasets for many algorithms in SPMF, the software you can find online. Okay, so let's start. Nowadays, we have a lot of data, all kinds of data in the database. And one thing we want to do with the data is sometimes to analyze the data to find patterns in the data that could tell us something about the data, help us to understand the data and so on. So, in data mining, there's one field of research. It's called the pattern mining. We want to find these patterns in the data. And in that field, there's a popular task. It's called the frequent item set mining. The goal is to find some sets of values, some item set, that appear many times together in the data. So let me give you an example. For shopping, maybe we look at the data, we use some algorithm, and we find many people buy bread, milk, and eggs together. Okay, so this could be a frequent item set. The items people buy many times. So if you find this, maybe you can do marketing, do some promotion to try to increase the money and so on. Okay. So there have been a lot of paper about this, frequent item set mining, and many applications also, not just for shopping. But one limitation I want to talk about today is that it does not consider the time, but the time is important. Because the behavior of the customers maybe can change over time. Okay. And also, we can find some regularities over time. Something might appear again, and so on. Okay. So the time is very important. So today I will talk about one extension of frequent item set mining to consider the time. That is called the periodic pattern mining. So briefly, what it is, the idea, we want to find some patterns in the data that will be periodic. Periodic means repeat over time. Okay. So for example, for shopping, we might find that many people buy tomato, wine, and cheese every week. Okay. So if we find something like this, it is very, very interesting because it tells us about the habits of the customers. Like, some people always buy this every week. Okay, so maybe we can do the promotion and so on. So first, I will need to explain briefly what is frequent item set mining. Frequent item set mining, the goal is to analyze the database where we have some values we'll call the items. An item means some symbol, some categorical value. So here, for example, to make it simple, I will use the data about shopping, but it could be other types of data. But we have a set of items we call I, and there will be some items like A, B, C, D, E, F, G. These are the values that we can find in our data. So in my example, it is about shopping. So A means apple, B for bread, C for cake, D for dates, E for eggs, and so on. Okay. So we have some items. Now in frequent item set mining, we want to find the sets of items, the item sets, that appear many times. So we need to set a parameter called the minimum support or min sup that must be greater than 0. Then the goal is to find all the frequent item set. That means the item set that have a support, means appear in the database at least min sup times. Okay. So here I show you an example of database about shopping. We have a database of 4 transactions about what the customer have bought. Okay. So in the transaction 1, the customer bought A, B, C, D, like apple, bread, cake, and dates. In another transaction, maybe the same customer bought apple and bread. In the third transaction, the customer bought apple, date, and eggs, and so on. So here we have the data, and then we set the parameter, the minimum support, and we want to find the patterns appear many times, the item sets. So how does it look like? Okay, let's look at an example. So if I have the same database here, and let's say I set the minimum support to 2. That means I want to find all the combinations of items that have been purchased at least twice, okay, 2 times or more. So the result will be what you see here. B, for example, is a frequent item set bread, because B appears 1 time, 2 times, 3 times. It is at least 2. Another example, like AB also is a frequent item set, because we have AB, AB, and AB 3 times. It is at least 2. So this is a very popular problem in data mining. Okay, I made some video also about this before. You can watch if you want to know more. So it is useful to understand about the customers, but there are some limitations. One important limitation is that it does not consider the time. But in practice, the time is important. So, for example, the behavior of the customer maybe will change over time, or maybe it will have some regularities. So, if we consider the time, there are many types of patterns we can find, like the periodic patterns, the peak, the trending patterns, and so on. Today, I will talk to you about one type we call the periodic patterns. Maybe another day I talk to you about others. Okay. So let's define what is periodic item set mining. The goal will be to find some groups of items that will appear periodically in a sequence of transactions. So again, we have transaction, but now we consider the time. We want to find something that will appear over time, will repeat itself over time, like people buy something every week. So for example, maybe we will find that people buy some bread, some cheese, orange, and this will happen every week or every few transactions and so on. So how does it work? Let me explain the basic problem for periodic item set mining. You will see it's not difficult. So the basic problem, it is you can look at this algorithm called PF growth, proposed in 2009, okay, to give you some idea. So the input will be again a transaction database like we saw before, but here I use another example, okay. And the user will have to set 2 parameters, the minimum support and also a new parameter, max per. We call that means the maximum periodicity, okay, to find the periodic pattern. And the result will be all the frequent periodic patterns. So how does it work? Okay, I need to give you some definition, then we will see some example. So let's have a look. So first we need to define what it is, the periodicity. So let me give you some definition. We say that the periods of an item set will be the number of transactions between each occurrence of the item set. So let me explain this with an example. Okay. Here we have a database. We have 7 transactions. We suppose that T1 is the first transaction, then there was T2, then T3, T4, T5, T6, T7. So there is some order of the time in this database. Now let's look at the item set AC. Okay, we want to find what are the periods of AC. We call this PS, okay, of AC. So PS of AC will be the periods of AC. That means the gap between each occurrence of AC. Okay, so let's have a look how to calculate. So first, we have AC at the beginning of the database, AC in the transaction 1. So here we need to think, this is a special case actually, okay? AC appear in the first transaction. So we assume that maybe AC was there before, okay? We don't know because we don't know what happened before. But from T0, let's say there's a transaction T0 to T1, the difference is one transaction. So we say the first period of AC is one transaction. This is a special case, okay? Now we need to continue. Let's look at AC. It appears again in T3. So 2 transactions later, after T1, we have AC again. So we say the second period will be 2 for AC. Now we need to continue again. AC appear again in T5 after. So 2 transactions later, we have AC again. So we say the next period of AC is a 2. After that, we have AC again in T6. So 1 transaction later. So now we have 1, 2, 2, 1, okay, for the period. And then we don't have AC again, but this is a special case, okay? It is the last time we see AC. So we count AC in T6 and to the last transaction, T7. So 7 minus 6 will give us a 1, okay? So this is again a special case. For the first and the last period, it is special. So now we have the periods of the item set AC. It tells us that this item set AC appear every about 1 or 2 transactions. The people always buy A and C together, like apple and cake. Okay, so let's continue the definitions. So now we have another definition. What is the maximum periodicity? So it is very simple. The maximum periodicity of an item set X will be the maximum of its periods. Okay, so if we have the periods of X, like AC, you want to find the maximum of this. So let's look at the example. Okay, so we found before that the periods of AC are 1, 2, 2, 1, 1. What is the maximum of this? Okay, so the maximum period of AC will be the maximum of 1, 2, 2, 1, 1, the largest value, so it will be 2. So that's all, okay, very easy to calculate, right? So now, what is a periodic item set? An item set will be periodic if the maximum of the periods of this item set is smaller than the threshold set by the user, the parameter from the user. So that's all, okay. So now let's look at some example to put all these definitions together to understand, okay. So briefly, okay, we found that the maximum periodicity of AC is a 2. So now, let's say we want to find the periodic patterns that have a maximum of 3. So AC will be periodic because 2 is smaller than 3. Now, another case, let's say we change this. We want to find the patterns that have a maximum periodicity of 1. Then AC is not periodic because 2 is greater than 1. Okay. So now I will show you a full example about this. So on the left, you have a table, again the same example, and let's say the user will set the parameter, the minimum support to 3, and the maximum periodicity to 3. So the result will be like this. The result will be what we call the periodic frequent item set. So we find all the item sets that have a support that will be at least the minimum support, 3 or more, okay, as you can see here. And the maximum periodicity of these item sets will be no more than the maximum here, 3. So these parameters, it is the user need to set. And then we find the result like this. So this is quite interesting, okay. So how to find the periodic item set? Now, if we want to design some algorithm to find these patterns in the data. So there are two basic algorithms that have inspired many other algorithms. The first one is a PF growth in 2009, and basically it is based on FP growth, okay. Another one is MTKPP based on ECLAT. So these two algorithms have inspired many other algorithms. So the key idea, without going into details, they use a property to avoid looking at all the combinations of items, because we want to find only the periodic item set. So there is a powerful property. It says if an item set X is not periodic, any superset of X is also not periodic. So for example, if AC is not periodic, then the superset like ACD cannot be periodic. So we don't need to look at all these other supersets, the combination like ACD. So this can save a lot of time. So this is the basic idea to find the periodic item set in the data. It's not very complicated, okay? You just need to change the algorithm for frequent item set mining to calculate the periods and use the property to reduce the search. Now let me explain to you more interesting things about this. So we can make some observation. First, the definition I have shown to you in the traditional problem is too strict, really too strict. Because let's say you set the maximum periodicity to 5. Maybe an item set will always be periodic, but only one time it will exceed the maximum periodicity, and then the item set will be discarded, okay? So for example, you have an item set appear every week, but only one time it appears after 1 week and 1 day, okay? Then the algorithm will eliminate this item set. So this is very strict. So there have been some solution to fix this, okay? So let me show you the more general model that is a generalization of the traditional problem. So it was proposed by me in 2016 for the PFPM algorithm, okay? So we saw that the traditional problem is really too strict. So we propose a solution. The solution is as follows. We say that an item set is periodic if the average periodicity of that item set is between some minimum and maximum. So we don't just look at the maximum periodicity. Here we try to find the average to see the item set. On average, is it periodic or not? Maybe not all of the time, but most of the time, on average, is it periodic? And also we look at the minimum periodicity and the maximum. So then the user has to set 4 parameters: the minimum, maximum periodicity, and the minimum and maximum average. And this problem is more general, because if you remove the 2 first lines here, then you get the traditional problem. But here you have more flexibility. You can use more parameters, and if you don't want to use all the parameters, you can remove some, okay? You can set the minimum to 0 or the maximum to the infinity and so on, okay? So this is really a more general problem. So let me show you now how it works. I want to show you with examples. So let's look again at the item set AC to understand the main idea. Okay. The periods of the item set AC are 1, 2, 2, 1, 1, as I explained before. Now, we want to find now the maximum periodicity. So this is what I explained before. Okay, the maximum of 1, 2, 2, 1, 1 will be 2. Okay, so this is the maximum. Now, here we have the minimum also. So the minimum will be the smallest value between 1, 2, 2, 1, 1. So the smallest value is 1. So here I have to say, there are also some special case I did not explain. Okay, so in the paper about PFPM, we also, when we calculate the minimum, we remove the first and the last. Okay, to calculate. This is because sometimes the last or the first can have a 0, and we don't want this, so we decide to remove the first and the last. Okay, but this is just some details. And finally, we have the average periodicity. So the average periodicity of AC will be the average of 1, 2, 2, 1, 1. It is 1.4. So what does it tell us to us? That AC appear, the minimum is every 1 transaction people buy AC. The maximum is 2. And on average, every about 1.4 transactions, the people buy AC. So this gives us more information than in the traditional problem. So now let's look at a full example. We have the transaction database like before, and we set the minimum periodicity to 1, the maximum to 3, and the average we want it to be between 1 and 2. Okay, so this is more flexible than the traditional problem. So we'll find the periodic item set like this. So for example, we find AC, the minimum is 1, the maximum is 2, and the average is 1.4. So 1.4 is between 1 and 2, so this is okay. The maximum of AC is a 2, it is less than 3, and the minimum is 1, it is at least 1, so AC is a periodic item set. So this is the main idea about this. Okay, it's not very complicated. So now, if we want to do the algorithm, how can we find, we do some algorithm to find the solution for this, to find the periodic item sets. So we designed the PFPM algorithm for this, and again, for this kind of problem, we don't want to look at all the possible item sets. So we need some property to be able to eliminate some combination, to reduce the search. So for this, you can see in the paper, we find a few properties that are interesting. So some interesting property, it is that the theorem 1, okay, if we have some item set X that are not the periodic frequent pattern, then X and all the supersets can be discarded. So if the maximum periodicity of X is more than the threshold, the maximum, we don't need to look at all the supersets of X. So I will not do the proof, but this is based on the lemma we had before. Okay. And another interesting property with the average periodicity. If the average periodicity of X is more than the maximum average, we don't need to look at all the supersets of X. So again, I will not do the proof, but if you want more details, you can look at the paper for this. So PFPM is the algorithm that can find the solution, the first one for this general problem. It is based on ECLAT. If you know ECLAT, you watch my other video, you know about this. So, like ECLAT, PFPM will do the depth-first search. It will start by finding the single item like A, B, C, and D. And then it will combine them to have two items like AB, ABC, and so on. And then, to eliminate the combination, we will use the theorems 1 and 2. So, if AB, the average periodicity, is too big, then we don't need to look the supersets of AB and so on. Then we can eliminate the search. So, PFPM is based on ECLAT. So, if you remember about ECLAT, if you know about ECLAT, for each item set like AC, we have a list of transactions. AC appear in T1, T3, T5, T6. So this is like in ECLAT. So having this list of transactions, we can quickly calculate the periods and then find the periodicity. So it is not difficult to modify ECLAT to get the PFPM algorithm. And also here I have the transaction like T1, T3, T5, T6, but also we can change this to have the timestamp instead, the exact time. Okay, it is possible to change the algorithm to have the exact time also. So that was a brief overview about the periodic item set mining. There are many other papers, so now I would like to give you an overview of a few interesting papers that I have read, that I find are interesting, bring some new idea. So in 2010, there was another paper from Alpha 1 based on FP growth that proposed some approximate calculation of the period. So the idea in this paper, they want to speed up the calculation to find the periodicity. So they will not calculate the periodicity maybe correctly, okay, but they want to do it faster, so the result will be approximate. So this is interesting idea. In another paper, there was another algorithm based on FP growth. So here, the idea is they want to set a different threshold, the maximum periodicity, for each item. Okay, so if you have 1000 items in the database, you can set a different value for the maximum for each item. So this is some interesting idea, but there's the problem that you need how to set all these thresholds. Okay, if you have 1000, you can use a function or other things, but still the model is very strict with the maximum periodicity. In 2010, there was another paper. Here, they decided to apply the concept of periodic patterns for the graph, for example. So instead of item set, it is for the subgraph. Okay. Another paper in 2012, there was the PFP algorithm based on FP growth. So here, instead of using the average or the maximum, they use the variance of the periods. So this is another measure to evaluate the periodicity, okay, the variance. After this, there are some other papers, like in 2015, it is my paper. So we extend the PFPM algorithm to find the periodic high utility item set. So we design an algorithm, again based on ECLAT and FHM, to find periodic item set that have a high utility, like make a lot of money, for example. So this is interesting. In another paper, in 2019, we extend this to multiple sequence. So in the traditional problem of periodic item set mining, you have only one sequence of transaction. But here we said, what about if you have many sequences? Let's say you have many customers, okay, in a store. So we want to find some periodic patterns that will be periodic, not just for one customer, but will appear for many people. Okay, so here we extend this. We are the first to extend this for many sequences. Another paper we did is to find the patterns periodic in many sequences that are rare, not just frequent, but that have the high correlation also. There is another interesting paper by Nofong in 2016, where instead of the average, they use the standard deviation of the period. So this is another measure. But not only this, they use also the statistical test. So they want to find the pattern that will be significant, not just random. Okay. So a lot of algorithms will find the patterns that are periodic, but maybe not significant. So here it is more complicated, but they use the statistical test to find the significant pattern. So this is interesting work. In another paper, it is my paper, we got the Best Paper Award at a conference by introducing a new problem called the stable periodic pattern. So the idea is, we observe that in the real data, it is not always very stable. Okay, you can find the patterns that are periodic, that sometimes are periodic, but not always, and so on. Okay, so here we want to find the periodic patterns that will be very stable over time. So let me show you this with a picture. Here we have the time, and we have some arrows that represent the size of the periods. So for example, we have a pattern appear every 2 weeks, 2 weeks, 2 weeks, then maybe 3 weeks, 3 weeks, and 3 weeks, and so on. So this is very stable, okay, always about 2 or 3 weeks. But sometimes maybe we have the unstable patterns. So patterns appear every 2 weeks, then after 6 months, then 2 weeks, 2 weeks, 2 weeks, and then 6 months. So in the traditional problem of periodic item set mining, maybe the patterns are not stable. So here we designed the algorithm to find the stable patterns. Make sure they are really stable over time. Now, another interesting problem to go beyond this, to find something more useful in real life, we made another observation. Maybe the patterns are only periodic during some time interval, but not always. So maybe a pattern is only periodic during the summer, for example, but not during the whole year. So we designed a new problem to find the local periodic pattern. We designed algorithms based on FP growth and ECLAT and so on. So here what we do, we find, for example, as you can see on the picture, that a pattern will be stable during some time interval, but maybe not during the rest of the year. So automatically we can find when a pattern will be stable. So this is also very interesting. Okay. So in conclusion, today I give you some introduction about periodic item set mining. I show you the basic problem. It is too strict. Then I show you the general model problem with PFPM, the PFPM algorithm. And then I show you some other extension to find the stable patterns and so on. Okay. So if you want to try this, you can have a look at the SPMF software. There's the code and the data, some very efficient implementation of these algorithms you can try on your data. So that's all for today. Thank you for listening.